All right, here we are continuing with Unit 4. Today our lesson is 4.2, which is imaginary numbers. Our objective for today, guys, is students will be able to find the roots of the equation when there is an imaginary number. So in the real number system, it's not possible to take the square root of a negative number. We've seen that before. If you enter that on the calculator, it is going to say error undefined, no real result. So what we want to consider is exercise 1. It says on the axis I sketched you y equals x squared. Now consider the parabola whose equation is given in a function notation as f of x is equal to x squared plus 1. You should remember from Algebra 1 that how are these two graphs different? How is this graph, which I have here, let's just label it y equals x squared, how is it different from the one that I just underlined? So the difference is that the graph, the new graph, the f of x, will shift 1 unit up because of this plus 1. So part B says I want you to sketch this on your axis. So get your calculator. Again, if you haven't done so, you should have. This is math class. Get your calculator and sketch x squared plus 1. Yep, look at this. This is what you should have gotten. On your calculator, I just sketched this here. It went 1 unit up. Now, what can be said about the x-intercept about this graph, f of x? What can you say about that? What do you know? Just look at the graph. Does this graph, f of x, intercept the x-axis? Does it intersect the x-axis? No. So what can you say about the x-intercept of the function y equals f of x? Is that they do not exist. That never happens. Now, algebraically, show that the intercept does not exist. So what will we do algebraically? So this is x squared plus 1 equals 0. So what's a fast way for me to solve for x? Minus 1 on both sides. This is cancel. And I'm left with x squared equals negative 1. Then I want to take the square root to get rid of the square. And this is x is equal to the negative 1, plus or minus. But we know that this, whenever it's negative under the radical sign, does not exist. Oops, does not exist. So what do we do now? And this is where today's lesson is going to talk. So we can't solve that. So what we need to do is, this is what's called an imaginary number. I. You will see the I that looks like this. This is my imaginary number. So the definition says that I is equal to the square root of negative 1. So we want to break all of this down. So look how simple this is. This, whenever there's a square root with a negative number, I'm going to break this down. This can be broken down as the square root of 9 times the square root of negative 1. And we all know what this is. Yep, the square root of 9 is 3, square root of negative 1 is I. And this is my final answer. Piece of cake. Let's look at this. B can be broken down as a square root of 100 and square root of negative times square root of negative 1. Square root of 100 is 10, square root of negative 1 is I. That's it. Now what about 32, negative 32? I know this can be broken down as the square root of 32 times the square root of negative 1. Now 32 can also be broken down as the square root of 16 times the square root of 2. And I'm bringing my square root of negative 1 down. How do I know it's this? You have to do the perfect square, the largest perfect square. Square root of 4. Square root of 16 is 4. The square root of 2 remains square root of 2 because I can't take anything. And then the square root of negative 1 is I. The I comes with the whole number. And this becomes 4i square root of 2. Let's see one more. 18 square root of 18 times the square root of -1. We know two numbers that multiply to get 18 are 2 and 9. Yeah. So this becomes square root of 9, which is a perfect square, and square root of 2, and bring this down. Square root of 9 we saw earlier is 3. The square root of 2 stays the same. And then the square root of -1 is the I. And you put all of these together. That is your final answer. Pretty easy. Let's move on. So I want to solve the following incomplete quadratic. And remember, incomplete quadratic means that there is no b term. So that's an easy solve. So what do I want to do? -8 on both sides. Oopsie, that's an 8. This becomes 5x squared is equal to -20. Divide by 5 on both sides. We have x squared is equal to -4. Then I want to take the square root of both sides. This is x is equal to, now, plus or minus square root of -4. Now, how do I do this? Remember, we just did this before. So, square root of, and I'm just going to come, just a side note here. Square root of -4 can be broken down as the square root of 4 times square root of -1. And we know this becomes what? 2i. So this is going to actually be plus or minus 2i, and those are my roots of my quadratic. So I'm going to take this off because I need space. Make sure you get this copied, okay? Now let's look at this problem here. B. Get every x squared by itself, x by itself, x squared and then eventually x, whichever one you want to say, -20 on both sides. This is half x squared is equal to negative, this is a 20, becomes -18. I'm going to get rid of my denominator by timesing 2 on both sides. This becomes 1x squared or x squared minus 36. Take the square root of both sides. I'm left with x is equal to plus or minus the square root of -36, which we know is the same thing as x is equal to plus or minus, where's my negative? 6i. So let's just make this a little clear. This is actually -36. Why don't you go ahead and try C by yourself and tell me what you get? Alright, you should have gotten up to this part. Set it up, add 10 on both sides, and then divide by 2. But then what happens here? This is not a perfect square like 36 and like 4. So, don't sweat it. All you got to do is, you know that if I take this negative out, it will be x is equal to plus or minus, you put the I in the front, square root of 13. These are not connected. Square root of 13. Remember, this right here can be broken down as square root of 13 times square root of -1. The square root of -1 is I, and then you're left with square root of 13. That's how I got this, and this is your final answer. Alright? Number 4. Which of the following is equivalent to 5i times 6i? Now, all this is 5i times 6i. We know 5 times 6 is 30, and then I times I is I squared. Correct? Now you got to kind of work backwards. This becomes 30. What's I? By definition, we know that I is the square root of -1 squared. Okay, again, What is I? Go to the definition that I gave you in the first thing of class. First thing in this lesson. What is I? I is negative square root of negative 1. So when I do this, this becomes 30 times the square root, and the square cancels off. This becomes negative 1, and then this becomes negative 30, which is choice 3. And this is how they ask you this on the Regents, so buckle up. The powers of I display a remarkable pattern, which we're going to talk about. There's a specific pattern. It's in circles of 4. We're going to get more into this into our next lesson. So, this is given. I to the first power is I. Anything raised to the first power is itself. I square. What is I square? We just said I is defined by the square root of negative 1 square, which is negative 1, because these cancel. I to the third is the same thing as saying I squared times I. I know I square is negative 1 times I, which gives me negative I. That's my final answer. Let me just box these off. And this was given. That's an I. I to the fourth, we know is I square times I square. Why does my square look so weird? This should be on this side. What is I square? I square is negative 1 times negative 1 is a positive 1. And that's kind of the pattern. But let's see this. I to the fifth. How can I break I to the fifth down? You can say it's I to the fourth times I. I to the fourth is 1 times I is I. Remember, the rule is when you have the same base, you just add exponents, and this is my invisible 1. So that's 4 plus 1 gives me 5. Now 6, I can break this down as 4 times I to the second power. You always want to go with increments of 2, not break this down as I squared times I squared times I squared. That's just a lot more work on you. I to the fourth, again, is 1 times I square is negative 1. Perfect. So this becomes negative 1. I to the seventh is I to the fourth times I to the third. The I to the fourth is 1 times negative I becomes negative I. Anything times 1 in itself. And then the last one, I to the fourth times I to the fourth. This becomes 1 times 1, which is 1. Notice the pattern. I'm going to highlight it. It starts with I, negative 1, negative I, positive 1. So that's I to the first, second, third, fourth. And then it kind of circle back. 5, it starts with I, negative 1, negative I, and positive 1. It kind of circles. So we see from this pattern that the powers of I are either negative 1, positive 1, I, or negative I. And these problems repeat. There you go, guys. Today's short lesson. Work on those practice problems. Guess what? Don't say it's too hard, Miss Samu. You can do this. All right? Good luck.